Okay, pre-calc students, last class we solved rational equations, and today we're going to graph rational functions. There are two kinds of rational functions we're going to graph, and the first kind is transformations of the parent graph y equals 1 over x. So here's our parent graph. It's graphed right here, and it has a vertical asymptote at x equals 0. And a horizontal asymptote at y equals 0. So here's our vertical asymptote, and here's our horizontal asymptote. Because of the asymptotes on both axes, we don't have any x-intercepts or y-intercepts. But this can change with transformations. The range is going to be everything except for 0, so negative infinity to 0, leave out the 0, and 0 to infinity. And the domain is going to be everything except for 0 as well. The end behavior of a rational function is interesting because the end behavior does not go to infinity or negative infinity. If you watch this branch, it's getting higher and higher and higher, but it's not going to cross that asymptote. So the end behavior is actually equal to the asymptote. So as x goes to negative infinity, f of x is getting closer and closer to your asymptote. It's getting closer and closer to 0. And the same thing happens on the right side. As x goes to positive infinity, f of x is going closer and closer to 0. To transform your function, you'll see values in your numerator here, which will cause a stretch. And it stretches if your a is greater than 1. And it compresses if your a is between 0 and 1. It's going to reflect across the x-axis if your a is negative. Translations happen with these values h and k. So if you want to translate it horizontally, you'll have x minus h. And if you want to translate it vertically, you'll have x plus k. You'll have f of x plus k. Okay, so here are the steps to draw the translations. First, start by drawing your asymptotes. If it says x minus h, then h is where your asymptote is going to be, vertically. And then the plus k tells you where your horizontal asymptote is, y equals k. Then you're going to plot points on each branch. Sometimes you can find the points because they may be the y-intercept or the x-intercept, and sometimes you'll just plug in values to the left and to the right of the asymptote so that you can find these points on your branch. You're going to draw the two branches, and remember that they should be getting closer and closer to your asymptotes. Okay, turn the page. Alright, let's try this out. First we're going to move our asymptotes. So because it says minus 2 at the end, I want to move this asymptote down to y equals negative 2. And then the plus 1, remember, this is happening inversely, so it actually moves our asymptote to x equals negative 1. And now we want to plot some points. Normally, our parent graph would have a point that goes from where the asymptotes cross over 1 and up 1. And because this number here is a 1 as well, it's going to follow that same pattern. And then our parent graph also, from where the asymptotes cross, you can go over 2 and up a half. You can go over a half and up 2. And so because there's no stretch or compression, that pattern stays the same in the right branch and also in the left branch. So go over 1, down 1, and go over 2, down a half. And you have 2 branches. So the transformations were left 1, down 2. The vertical asymptote, when it shifted left 1, it was at x equals -1. And the asymptote exists there. Think about that for a moment. What would happen to -1 if you plugged it into the function? It would make your denominator 0. So the asymptote is at -1 because that's the value that makes the denominator 0. So where is the horizontal asymptote? That shifted down 2, so it's at y equals -2. And the y-intercept. So we haven't found the y-intercept. To find the y-intercept, you want to make your x value 0. So I'm going to have y equals 1 over 0 plus 1 minus 2. 0 plus 1 is 1. 1 over 1 is still 1, so I get 1 minus 2 equals -1. So my y-intercept is at 0, -1. Let's see. That matches right there. The x-intercept, you want to make your y value 0. So you have 0 equals 1 over x plus 1 minus 2. So to solve for x, first I would add 2 to both sides. So I would get 2 equals 1 over x plus 1. And then multiply both sides by x plus 1. That would cancel out the one on the right. So on the left, I'll have 2 times x plus 1. On the right, the x plus 1's canceled, and I have just 1. So I'll distribute, and I get 2x plus 2 equals 1. And now I'm solving just a linear equation. 2x equals -1, and x equals -1/2. So x equals -1/2 is right here, and it looks like our branches follow that pattern as well. The domain and range, you want to have everything except for the asymptotes. So from the left, you start at -infinity all the way up until -1, but leave -1 out. So your domain is -infinity to -1, leave it out, and -1 to infinity. Your range starts at the bottom at -infinity, and it goes up to -2, but you have to leave that number out. So -infinity to -2, start right up again after -2, and go to positive infinity. Alright, for the next one, let's analyze it before we graph it. So what transformations do we have? We still have some shifts. We have shift right 3, and up 4. This time, though, we have a 2 in our numerator, so that's a stretch of 2, and then the negative is going to flip vertically. So let's see, stretch by 2 and reflect vertically. So when we shift right 3, that shifts our vertical asymptote to x equals 3. And when we shift up 4, our horizontal asymptote becomes y equals 4. The y-intercept, we're going to put 0 for the x, so we have y equals -2 over 0 minus 3 plus 4. The negatives here will cancel, we'll get 2/3, so we get 2/3 plus 4, which I'm just going to write as 4 2/3. So my point is 0, 4 2/3. For the x-intercept, we need to make the y 0. So I have 0 equals -2 over x minus 3 plus 4. Subtract 4 from both sides. I have -4 equals -2 over x minus 3. Multiply both sides by x minus 3. So I have -4 times x minus 3. On the right side it cancels, and so I have just -2. Distribute, -4x plus 12 equals -2, and just solve your linear equation. -14, so x is going to be 14 over 4, which is 7/2, which is 3.5. So So this is going to be 3.5 comma 0. Alright, domain and range, let's do that up here. And actually, let's do the graph first, and then we'll do our domain and range. So we want to move our vertical asymptote over to x equals 3. And let's grab the horizontal asymptote, and that goes to y equals 4. Normally, we would have a point that's over 1 and up 1, but because of the -2, our branches are going to actually end up on the top left and on the bottom right. And we're going to go over 2 and down 1, over 1 and down 2. That's going to give us our stretch of 2, and then the negative is what flipped it vertically. Remember, your branches still are going to go closer and closer to your asymptotes. As I approach my x-axis, I'm remembering I know what my x-intercept is. I got 3.5, so let me graph 3.5 and then make sure that my branch goes through 3.5. It didn't quite work out for me. I'll try that again. So here's 3.5. Let me go back this way to go through my points. Remember your arrows at the end. And then I know my y-intercept too is 4 2/3, so that's right here. I also know that from where the asymptotes cross, I'm going to go right 2 and up 1, and right 1 and up 2. So I have 3 points on this branch. Okay, now we're ready to write our domain and range. The domain is everything except for the vertical asymptote. So domain, -infinity all the way up until 3. Leave out the 3 and go to infinity. The range is everything but your horizontal asymptote, so -infinity all the way up to 4. Leave that out and go 4 to infinity. Okay, so that was your first 2 pages. There will be a new video for pages 3 and 4. Remember to continue writing notes in the margin, even though we didn't set a special space aside for that, so that you can ask all of your questions in class.